Hi students, now let us see the different scheduling algorithms that are present in the operating system. So the operating system that is designed by using some different scheduling algorithms. So based on the user's request, that scheduling algorithm will be used. So the different types of scheduling algorithms that are present in operating system is first come, first serve. So we already know about this. So this is the FCFS scheduling, first come first serve. And next, shortest job first, shortest job first, SJF scheduling. Next is a priority scheduling, priority scheduling. And the fourth one is round robin scheduling, round robin, that is RR scheduling. So these are the four different types of scheduling algorithms that are used in the operating system. So here the names are indicating that it's give the clear idea to all of you. So here saying the first come first serve scheduling means what it's saying, that the process that comes first, that has to be executed first, that is the first come first serve scheduling. Next algorithm saying that shortest job first scheduling. So this name is indicating that you have to take the process that time of execution should be the shortest, that has to be taken first. The shortest job first, that process has to be executed first. And next algorithm is saying that priority scheduling. It indicates the priority, which process is having the highest priority, so that process has to be executed first. And round robin scheduling means here it is rotating in the circular fashion, means round robin, means here we are assigning some constant quantum time. So in that time, that process has to be executed. Suppose if the time is over, the CPU criteria time is over, it goes to the next process. So after completion of that, all the process again execute the first process. So in the round robin fashion. So that's why the name you call it as a round robin scheduling. So here we allocate some fixed time to that each process. So this is just an overview of this scheduling algorithms. Now let us discuss one by one with an examples. The first algorithm that I am taking here, the first come first serve. So let me explain about the FCFS. So what is this FCFS algorithm? Now let us see that. I am taking one simple example for this FCFS. The CPU will take the process in FCFS, the first come first serve method, in a list. Let me take one example. This is the process I am taking, and here the burst time. I am taking three processes, P1, P2, P3, and the burst times for that process is 24, 3 and 3. So you know about the process. The program that is currently being executed, that you call it as a process. Then what about the burst time? What do you mean by burst time? Burst time is nothing but the time CPU taking the control of process, means how much time it is the CPU is handling this process, that you call it as a burst time. Burst time means the time the CPU taking the control of process, how much time that CPU is going to be execute that in process, means up to 24 of time limit it can execute, that process can execute in the CPU. So that is the time allocated to each process by the CPU, that you call it as a burst time. Now let us take, suppose the processes are arrive in the order. Let us take, suppose process or arrive in the order. Let us take they are arrive in the order P1, P2, P3. The first P1 came, next P2, next P3. So how it is going to be occupied in the, so first P1, from the burst time of P1 is up 0 to 24. Next P2. P2 burst time is 3. So if you add 3 to 24, this is the 27. And the burst time of P3 is 3. So just add 3 to this 27. This is 30. Now calculate the waiting time of this each process. So waiting time for P1. So P1 waiting time is 0 because the starting only it is going to be executed. So the P1 waiting time is 0. Next coming to the P2. P2 waiting time is 24. The P2 waiting time is 24. Means it has to wait up to 24. Next P3 waiting time is 27. So P3 waiting time is 27. So whenever the 27 is came, the P3 is going to be executed. Means the CPU is taking the P3 process. So that is a waiting time. So this process has to wait in the queue. So the P2 has to wait in the queue up to 24. And the P3 has to wait in the queue up to 27. So that you call it as a waiting time. The process that is waiting in the queue, that you call it as waiting time. Now what is the average waiting time? Average waiting time of this first come first serve is 0 plus 24 plus 27 by 3. So you will get 17. 17 is the total average time of this process that has to be executed in the CPU. So this is the order I have taken, P1, P2, P3. Suppose if I take the order like, suppose if I change the order. Now let us see what is the average time if I change the order. Suppose the process will arrive in order P2, P3, P1. Now let us see. So P2 starts from 0 and the P2 burst time is 3. Next P3. P3 burst time is 3. So 3 plus 3, 6. Next P1 burst time is 24. Okay. So 24, 6 plus 24, you will get 30. So this is okay. From 0 to 30, the CPU will be execute all the process. So that is the same in the previous example, and here also you will get the 0 to 30 only, but the waiting time will changes. Let's see how it is. Waiting time for P1 is, the P1 waiting time is 6, 0 to 6. So up to 6 it has to be wait in the queue, and the P2 is 0 and P3 is 3. So average waiting time is 6 plus 0 plus 3 by 3. So you will get the answer 3. So if you take the order as P1, P2, P3, you will get the average waiting time is 17. If you take the order P2, P3, P1, you will get the average waiting time as 3. Okay, means whenever the process you are taking in the queue, that is the different, but here the waiting time is also changing. So it is much better than the previous case. So this is a problem that will arises in the FCS. So let me write the problems. What are the problems that are arised in this the facing the first come first serve? Problems with first come first serve, or first one thing, it is a non-primitive. It is non-primitive algorithm. Why I am saying this is a non-primitive algorithm? Because the process has to be has no choice. It has to be execute that process which is present in the queue next. So whatever the process that is executing waiting in the queue, that process has to be taken by the CPU. There is no option for the CPU, because here we are not considering the priority. So that's why the first come first serve is a non-primitive algorithm. Means the process doesn't The process priority doesn't matter here. Next one, improper process scheduling, that is a high priority process have to wait. This is the improper process scheduling. Why I am saying this is an improper? Because if you take the process P2, P3, P1 like that, you will get one average time. If you execute P1, P2, P3, you will get another average waiting time. Means that this is an improper process scheduling. So if you give the one pattern, you will get one answer like that. And the next, resource utilization is parallel. Resource utilization in parallel is not possible. In FCFS, resource utilization in parallel is not possible. That which leads to Conway effect. And hence poor resource utilization means the poor CPU IO utilization. If you use the first come first serve algorithm, it leads to a poor resource utilization. The poor CPU and IO utilization will becomes degraded. So what is this Conway effect? Here they are saying that if the resource utilization in parallel is not possible, it leads to the Conway effect. Conway effect means in which whole operating system slows down due to few slow process. Due to some few slow process, the whole operating system is going to be down. So that you call it as a Conway effect. So that which leads to the poor resource utilization. So these are the problems that are raised if you use the first come first serve algorithm. Thank you.